Alrighty, these are special binomials that factor in a special way. And so we're going to look at these so that you can have a shortcut method so you won't spend time working on problems that you don't need to work on. So let's look at these factors and let's go ahead and multiply those two binomials together. And I'll use a square for the first one. I have x plus 4 and I have x minus 4, and I'm going to multiply. X times x is x squared. X times negative 4 is negative 4x. X times positive 4 is 4x, and positive 4 times negative 4 is negative 16. So you'll notice that these guys are going to add up to 0. So I really have x squared minus 4x plus 4x minus 16, which these guys cancel out. And so I end up with x squared minus 16 for my answer. And so I'm going to write that, I guess, at the bottom, x squared minus 16. Okay, I'm going to use the break apart method for this one. I'm going to have 2x plus 5. I don't know if this is going to fit. And then I have 2x minus 5. 2x minus 5. So when I double distribute, I end up with 4x squared minus 10x plus 10x minus 25. These guys can't make 0, cancel out. 4x squared minus 25. Hey, I think there's a pattern here. That would be the goal, is to say, hey, there's a pattern here. All right. Last one, I'm going to do FOIL, which some of y'all noticed before and some of you didn't. I'm going to do the first terms. Ooh, it didn't like that. First terms, inside terms, outside terms, last terms. So 3x times 3x is 9x squared. 3x times 2 is 6x. 3x times negative 2 is negative 6x. And 2 times negative 2 is negative 4. I end up with a 0 here. And so I get 9x squared minus 4. Hey, look at that. Look at those. I probably don't even know that. That was so long ago. Okay, so what do you notice about each of these expressions? The b term is 0 because I don't know which one to say. Okay, never mind. That's all. What do you notice about them? And what do you notice about them in expanded, okay, in factored form? I guess it's expanded form. In factored form, I hope you notice that the numbers were the same. Let's just start over. The numbers are the same. And one is minus and one is positive. So you had a plus and a minus. You had to have one of each. And the numbers in each set of parentheses, the binomials, were the same. That's what's in the parentheses. So the binomials were the same, except that one was adding and one was subtracting. So when we got to the expressions in standard form, the b's canceled out. They're the same value and canceled. Which means, I don't even know if that's how you spell cancel. Are there two L's? Canceled? That still doesn't look right. Canceled. Okay, I'm not gonna worry about that. B equals 0. All right, so what do you want your rule to be? Write your own rule. How's the best way to think about this so that it makes sense to you? A plus B times A minus B is equal to A squared minus B squared. And really that should be A plus C probably, but so let's just say this is called the difference of squares. So when you see these, and you're going to have to follow, you're going to have to look for them, because I don't want you to look at x plus 9 and x plus 9 is not the same as x plus 9 times x minus 9. But when you do see this specific form, you can just multiply the first term, multiply the last term, and know that the second term is going to cancel out. So I don't need to put plus 9x minus 9x because that'll be gone. And my answer is x squared minus 81. For number 2, my answer is 4x squared minus 49y. For number 3, my answer is 36y squared minus 25. So all I'm doing is squaring the term. Oh, this probably has a square. All I'm doing is squaring the terms, and I end up with squares. Okay. So what our answers were are perfect squares. All these are perfect squares. What makes a perfect square? All right, this is a perfect square. This is not a perfect square. This is a perfect square. Okay, a perfect square has to have the variable has even exponent, and the coefficient, we learned that's the word for the number, coefficient. I'm having spelling problems today. Coefficient, that doesn't look right, has to be a perfect square. So when I say perfect square, I hope you know what kind of numbers I'm talking about. I'm talking about the numbers that when you take the square root, you get a whole number. 6 has a square root, but it's a decimal. 16 has a square root, and it's a whole number. That's why this is yes, this one is no, because it's a decimal. It's 2 point blah, blah, blah. Okay, so now that I know that, I can take the square root of my two terms. I'm going to take square root of that, square root of that, and one is going to be plus and one is going to be negative. So square root of 4x squared is 2x. Square root of 81 is 9, so I'm going to have plus 9 minus 9. If I was going to put 8, then that'd be wrong. Okay, so I have 2x plus 9, 2x minus 9. For number 8, the square root of 9x squared is going to be 3x. And 3x, square root of 49 is 7. So I have plus 7 minus 7. So when you have perfect squares, and you should know most of your perfect squares. 1, 2, 9. Did I skip one? 1, 2, 9, 16, 25, 36, 49, all those. 64, 81. Okay. Blah, blah, blah. So let's look at number 9. Square root of 25x squared is 5x and 5x. Square root of 16y squared is 4y, so I have plus 4y minus 4y. And it's that easy. Don't do this when it's not a perfect square. Okay, number 10. 8 does not have a perfect square, or is not a perfect square. But I do notice that I can take out a greatest common factor of 2, which makes this 9x squared. Actually, I could take out Let's take out some x's. Let's start over. Okay. So 8 isn't a perfect square, but I could take out a 2 and an x squared actually. So if I take out 2x squared, I end up with 9 minus 4. Did I say x? Oh, no, I can't. Okay, let me do that one more time. Okay. Hey, I noticed that 8 doesn't have a, we'll just like keep doing this over and over again until I get it right. Hey, I noticed that 8 is not a perfect square, so I can divide everything by 2, not by x, because the other one doesn't have an x. So I end up with 9x squared minus 4y to the 6th. Okay, and don't forget your 2. The square root of 9x squared is 3x and 3x. And the square root of 4y to the 6th is going to be 2y to the 3rd. Remember, when I take a square root of an exponent, it's just cutting it in half. So I have plus 2y to the 3rd minus 2y to the 3rd. And there you go. Boy, that took a long time. Okay, same thing for number 11. 48 is not a perfect square, nor is 27. I'm going to take out a 3 and an x because I know 3 goes into 27 9 times. My x is gone. And 3 goes into 48. 3 goes into 4 1 time with 1 left over, and 3 goes into 18 6 times. And I took out one of my x's. So I have 3x. Square root of 9 is 3. And I have square root of 16x squared is plus 4x minus 4x. And that's my answer. Number 12, these are perfect squares. 4x squared, the square root is 2x and 2x. Negative, or 64, the square root is 8, so I have plus 8 minus 8. All right. 13, what's so lazy? I had some down here. 14 made me want to cry for a second, but then I figured it out. Okay, so 13. I have a square plate, and I want to make a rectangular plate. So here's my plate. It's going to be increase length, so this is x plus 4, and decrease width is x minus 4. So if I have the area, which is x plus 4 times x minus 4, I know that that's going to be x squared minus 16. So that's the new area. Okay. This one, ooh, and number 15. These all made me frustrated. Okay, so here's my area, and it's reduced, which means I'm going to subtract 147. So I have 27a squared minus 147 is my new area. So if I want to take the difference of the squares, I know that 147 is divisible by 3 because 1 plus 4 plus 7 is 12, and 12 is divisible by 3. So I'm going to divide by 3. I'm going to divide by 3. See how many times it disappears. So I end up with 9a squared minus 3 goes into 14 4 times with 2 left over, and 3 goes into 27 9 times. So I have this times 3. Don't forget your 3. So I know B is wrong. And I know A is wrong because I have to have 1 plus and 1 minus in my binomials. So which one is correct? Well, C, because I have the number outside. Okay, square root of 9a squared is going to be 3a. Square root of 49 is 7 plus 7 minus 7. Therefore, C is the right answer. Okay, 15. I had to read this really slowly. Combined area, congruent rectangles. Congruent means they're the same. Okay, and the area is 18y squared minus 8. And that's for 2 rectangles. And all I care about is 1. So the first thing I'm going to do is divide by 2. Because that will give me the area of one of my rectangles that are exactly the same. So I end up dividing by 2 and I get 9y squared minus 4. So this is for one rectangle. So now I need to take the area and figure out how long each side of the rectangle is. So if I take the square root of this, I'm going to end up with 3y and 3y. And the 4, square root of 4 is 2, so I have plus 2 minus 2. So one of my rectangles has one side which is 3y plus 2, and the other side is 3y minus 2. And I want to find the perimeter. So this side is 3y minus 2, and this side is 3y plus 2. So I add up all my sides. I have 3y, 6y, 9y, 12y. And I have plus 2 minus 2 plus 2 minus 2, which means they all kind of disappear, and I end up with 12y being my perimeter. There, that wasn't so bad. All right, last one. So how do you know if a binomial is the difference of 2 squares? 1, the numbers are perfect squares, or the coefficients, or the constant. Or you can take out a GCF. For example, in number 15 above, I divided by 2 and I got perfect squares. So 18 and 8 weren't perfect squares, but when I divided by 2, 9 and 4 were perfect squares. So I'm using 15 to explain what I just did. The numbers are perfect squares, or you can get to perfect squares by finding a GCF. And the binomial has to be, because when it says binomial, it's talking about x squared minus 9. Okay, it's talking about that kind of that's the binomial. It's got 2 terms. They have to be perfect squares, and it has to be a subtracting. That's a scary M. Subtracting. And I guess I should have put in number 1, but I'll put it in number 3, but I ran out of room. And the third thing is, oh, that wasn't good. And the third thing is, variable has to have even exponent. Can I just write even exponent? So it should be easy to recognize because it has to be a subtracting problem. There has to be perfect squares in the numbers, and the exponent has to be even. So those are the 3 things that have to be happening before you can just use this whole difference thing. A lot of you were doing this when the signs were the same. We had x squared, and I'll just do this in a different color because this was something y'all did before and it made me kind of cranky. If I have x minus 3 squared, it is not x squared minus 9. This is not x squared minus 9. Does not equal x squared minus 9. Because that gives me 2 negative signs. If I have x minus 3 squared, I have x minus 3 times x minus 3. My b values are not going to cancel out because they're both negative, and we're going to talk about that tomorrow. So make sure you remember this. Don't be willy-nilly and just assuming things are perfect squares or difference of 2 squares. All right, enough rambling. Goodbye.